Hello. Hello. So, I have been recently looking into orbitals in atoms, and I've been revisiting it. I learnt about it when I was at school and when I was at uni for a bit as well, and I've just been revisiting it. And it's funny, isn't it, how when you learn stuff as part of official education, I don't know about other people, but for me, I find it very difficult to stop and pause and think how interesting it actually is. Because I was always so focused on trying my best to just get my head around concepts and being able to pass an exam that it takes the joy out of learning, I think. So it's been quite fun sort of learning it again in a way that's completely stress-free. I don't need to pass an exam. It's very nice. So I thought I'd go through it with you. I bought a whiteboard as well, which, I don't know, we'll see how it goes. And also, I thought I would try a soft-spoken ASMR video because I've never done one before. And we'll see if you like it. I don't know. So, let's be calm and enjoy learning about orbitals. So, I need to get the whiteboard. It's pretty big. I didn't think it would be this big when I bought it. Okay, so this is going to be very I'm a novice. I'm not. Don't use this to pass your exams anyway. Okay, so you think of an atom. You've got your nucleus in the middle. So that's a bunch of protons and neutrons. And people think of the electrons around the outside. Something like this, don't they? And they think of them as sort of like whizzing around the nucleus, whizzing around all the protons and the neutrons there. That's not very accurate though. They don't orbit. So it's this website that I came across. I think it was put together by a biochemistry teacher, and it sounds like they get a lot of students who have this misconception that electrons orbit, because I guess when they were figuring out the structure of an atom way back then, they thought that electrons did orbit. That was one of the models suggested, I think. But now we know that's not true. Electrons are found in these things called orbitals. And orbitals and orbit is a very similar word, isn't it? So I think that's why it still confuses lots of people. But it's not the same thing. And let's talk about the orbitals. So let's, first of all, let's rub this one out, and now we'll talk about orbitals. So, okay. So an orbital is where, I need to figure out what I'm doing with this whiteboard. So an orbital is where 95. That's where an electron spends 95% of its time, and it's a region of space where it will spend that time in. And each orbital holds up to two electrons. So 2 electrons can orbit. No, 2 electrons can be found in an orbital as a maximum. You can't get 3 in an orbital, as far as I'm aware. And so we say 95%. Electrons spend 95% of their time in this space, this defined space, because an electron can be found absolutely anywhere. So if you wanted to draw a space, draw an orbital where, like, big enough that you can be 100% sure that the electron would be found in that space, you'd have to apparently draw an orbital as big as the universe. So yeah, that's pretty cool. I mean, I don't see how that happens. I guess electrons orbit, like, I guess electrons operate, is what I was looking for, operate in a way that's very different to how you would think that they would operate, because I don't understand how an electron can be found all the way at the other side of the universe when, you know, light would take billions of years to travel across the universe. You know, how would an electron travel faster than light to get over to the other side of the universe? I don't know, maybe I'm not fully understanding the concept, but there you go. Okay, so moving on, let's rub this bit out. So there's also something called the Heisenberg uncertainty principle, which I probably learned about it when I was at uni. So full disclosure, I went to uni for about 2 years and then I had to drop out, unfortunately. So I probably learned about the Heisenberg uncertainty principle at that time. I cannot remember. But basically the Heisenberg principle says that you cannot know where an electron is and where it's going next. So the position and the momentum of an electron. So for this reason, you can't know what an electron is actually doing in that orbital, how it's moving, how it's getting from one place to the next. That's not something that you can actually find out about, but you can, from what I understand, measure, okay, the electron was found here at this precise moment in time, and it was found over here at another precise moment in time. You can't know how the electron got from one place to the other because of the Heisenberg uncertainty principle. So there's one type of orbital called an s orbital. So let's draw it. Say if you think of the nucleus as a small dot here, in reality that dot would be much, much, much smaller. And then all around, this is going to take ages, all around is a very fuzzy spherical area that it would sort of dissipate at the corners. It become less dense, not the corners, at the outer edges become less dense, and in the middle it would be more dense. I should really have more colours really, but anyway, so there you go. So that's what we would call, it's a really bad drawing, but it's what we would call a 1s orbital. So 1 means the orbital is in the energy level closest to the nucleus, and S refers to the shape of the orbital. I don't know why it's called S. I don't know where they get the letters for the orbitals from, but this is an S orbital. And then if you were to get a 2s orbital, so it would be in the next energy level up, it would look a bit more like this. So if we were to, yeah. Okay, so I'm not too sure how how well I've drawn this, but so you'd have a region around the nucleus where the electron is more likely to be found. These are all the little points where an electron could be found, right? And it's quite dense near the nucleus. And there'd be a bit in the middle where it's slightly less likely to be found. And then because it's the next energy level up, there'd be a bit away. Yeah, it would be bigger. I haven't drawn this well at all, as you probably can't understand this. But think of this area as being much larger than the one I did previously because it's the next energy level up. So the next energy level up means that the electrons would be further away. They would more likely be found further away from the nucleus. So in reality, I should have drawn this whole circle quite a bit bigger than the first one. So the 2s orbital has a region of slightly higher electron density near the nucleus, which is what I've drawn, just referring back to my notes. And in 2s, 3s and 4s orbitals, so the numbers refer to the energy levels. As the numbers go up, the energy levels are higher and they get further away from the nucleus. So 3s and 4s orbitals, electrons spend more time slightly close to the nucleus than you might expect, which is why I've drawn this little bit of higher electron density there. And therefore the energy of the electrons in these orbitals is slightly reduced compared to other shaped orbitals. So, I don't know how much that made sense. I mean, as long as you're finding this relaxing, it doesn't really matter anyway, or tingly. So another type of orbital is called a p orbital. P orbital, 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 p orbital. Okay, so it's a p orbital, and the first of the p orbitals is a 2p orbital. So a p orbital looks more like this. So if we draw the nucleus in the middle again, there you go, there's a nucleus, and then it looks more like two balloons tied up in the middle. Oh gosh. Oh well, at least we're getting lots of tapping, aren't we? Okay. There you go. I think that's also like, slightly denser in the middle of these little balloon shapes, and then slightly less dense as you go to the sort of the outer edges. Right? There you go. Trying to see what I'm doing in the phone camera. There you go. This all works, doesn't it? There you go. Cool. Nice. Okay, so it looks like two balloons tied together at the nucleus. So the electron can't pass through the node. So the node is like this sort of plane there. The electrons cannot pass through this, which is really interesting. And I'd like to find out why, therefore, electrons can be found either there or there. They can be found there, and they can also be found there. How do they get from one to the other if they can't pass through this plane? Now that is apparently information for a higher level. I don't know the answer. If one of you has this sort of knowledge and wants to explain it in the comments, be my guest. I'd be super interested. So